for R.6 since the other one didn't have any sound. So replace it with this. So we're looking at rational exponents in section R.6. So the negative exponent rule, whenever we have something raised to a negative exponent, we can flip that. So it gets 1 over a to the positive n. And then we have our exponent rules, like when we're taking a product, so there's multiplication in here. So product there, so this can take care of the negative. All I have to do is just flip that. So then it's 1 over x times y, all raised to the positive 3. Now I can take that and distribute that 3 to everything in there, right? Because 3 means cubed, so it's 1 over xy times 1 over xy times 1 over xy. So that's 1 over x cubed y cubed. Same thing with this. I can flip that fraction because of this negative. I can flip the fraction 5 over 2 and then raise it to the positive 3. So that's 5 cubed over 2 cubed. So I get that. All right, so negative exponent rules. Basically like 2 to the third is 8, right? And if I decrease in order, if I increase, if I times it by 2 and I go 2 to the fourth, that is really just taking this 8 and multiplying it by another 2. So I get 16. So going backwards, going down, I would take that 8 and divide by 2. So if I drop a power, 2 squared, right, I take the previous answer, 8, and divide by 2, and I get 4. And if I drop down a power again to the first, we're taking this previous answer and dividing by 2. And then 2 to the 0 is taking the previous answer of 2 to the 1 and dividing by 2. So that's why I get 1. So that's why everything raised to the 0 power is 1. And then if I drop a power again, and I divide by 2, that's 1/2, which is same to the 1 over 2 to the power of 1. And drop a power again, I just divide this by 2, which is the same as multiplying by 1/2. And that's where I get 1/4, which is the same as 1 over 2 squared. So that's why I get that negative exponent rule. That's why I can just flip it and change the sign to positive. Here, quick is the quotient rule. So whenever we dividing by the same base, so dividing by the same base, we take these exponents in top minus bottom. So it's always top minus bottom. Whatever that answer is, it's always in the numerator, right? So I can go ahead and do this real quick. So this would be 3 to the negative 1, right? My exponent stays an exponent on all these, so it goes as an exponent, goes as an exponent, and then when we raise powers to powers, we multiply. So there's x to the negative 2, and then this would be times by 3 to the negative 2 and x to the negative 10. And then on bottom, we would have 3 to the negative 2, x to the negative 4. Now there's some ways we could move this whole thing to the bottom and this whole thing to the bottom because those negative exponents, we could just put them on bottom. So I could rewrite it as 3x squared now to the positive 1, 3 to the negative 1, x to the negative 2 squared, and then move this 3x to the fifth because it has a negative 2. I can move that just on bottom, and so I could do it like that, and then I could go ahead and raise powers to powers and stuff like that. So eventually, either way, you'll get the same answer. I guess I'll just continue this one. And so 3 to the negative 1 and 3 to the negative 2 is 3 to the negative 3. And then x to the negative 2 and x to the negative 10 is x to the negative 12. And on bottom, I just have 3 to the negative 2. Oops. 3 to the negative 2, x to the negative 4. So I'm dividing by the same bases here. So I get 3 to the negative 1, because minus 3 minus a minus 2 is plus 2. So that's where I get negative 1. So it's in the numerator currently. And then this would be x to the negative 8, which then I need to get rid of those negative exponents by moving them to the bottom. So 3x to the positive 8. Okay, so more dealing with rational expressions. Rational exponents. So that means when I have a fraction as an exponent. So whenever I have a fraction as an exponent, I can rewrite it in a few different ways. It basically means a root, a type of root. But I can rewrite it as doing a whole number times a fraction, right? So I can separate m over n as 1 over n times m, right? Because when we raise powers to powers, we multiply. So I could rewrite this as 125 to the 1/3, and that's being raised to 2. And then I can simplify what the cube root, or what times itself 3 times is 125, is 5, and then I can go ahead and square that. That's what that 2 is doing out there, and I get 25. So then this one is 27 to the 1/3, which is 3. 27 to the 5/3. Well, the third tells me what times itself 3 times 27, which I just found out was 3, and now I raised that to the 5th, which is 81 times 3, which is, I think, 243, something like that. And then this is this 27 cubed? And I don't know 27 cubed. So then I can simplify these. This would be 3 to the 6th. And on the bottom, I could rewrite that 27 as 3 cubed. And then that is being cubed from this thing right here. So that's really 3 to the 9th. So 3 to the 6th over 3 to the 9th. And then I can subtract, and I get 3 to the -3, which I can rewrite that as 1 over 3 to the 3, which is just 1 over 27. So I didn't have to use a calculator. I did all that just by using rules of exponents. You were so impressed, I know. Okay, factoring with negative exponents. So whatever you do, whatever the biggest negatives, that's what you're going to divide by, or that's what you're going to factor out. So my biggest exponent here is x to the -3, so that's what I'm going to factor out. And remember, factoring is kind of like undistributing. You're dividing, where factoring is multiplication. So you're kind of dividing out, so that's going to go on the outside, so that x to the -3 is going to go on the outside. Then when we divide by the same thing, we get 1, right? So then I get -8 over here. And when I divide here, I subtract my exponents. So here, when I subtract them, I get 0, right? Because a -3 minus a -3 is a +3, so that's going to be x to the 0, and anything that's 0 is 1, so that's why it's 1 times -8, and it's -8. Maybe I'm talking too fast. That's okay. You can handle it. You can slow down the speed if you want to. Here is going to, when I subtract, that's going to be a plus, right? So I get x to the 1st, and I still have that 12 out in front. So 12x minus 8, and I could factor the greatest common factor out of here, right, is 4. So I could really take out a 4x to the -3. And then I get 3x minus 2. And then I could simplify that. That's a negative exponent. So only the x is going to move because the 4 doesn't have a negative exponent. The exponent on the 4 is 1. So that would stay. And then just x cubed would go on bottom. So only thing with the negative exponent moves. Okay, so here's a little bit different. So this has a negative exponent, so that whole thing could go down to the bottom. And this is multiplication here. I'm not sure if it's supposed to be multiplication. I think it might be supposed to be adding. But I'll do multiplication. One of them's harder than the other. So if that's multiplication, then I just bring this to the bottom because it has a negative exponent. Now it's a positive exponent. And x to the -1 times y to the -1. So those I could flip on their own. I can't necessarily, I can go ahead and rewrite that. Since they're both being raised to the -1, I could rewrite them as xy raised to the -1, and now I can bring this to the top. So that looks like xy, that's being raised to the -1 all over x plus y. Now it's a positive 1. There you go. So now I don't even need that. And so there, it looks like that. But I think maybe it was actually supposed to be a plus, probably. Which then the bottom, this one's probably the harder one. Because of the negative exponents, I flip those like that. And then, so then I can bring down the bottom like I did on the other one. But this is a binomial. So it would have to be like this. And then I would have to FOIL that out. So that's taking x, y times both of those terms. So I get x plus y over x plus y over y. And that's all over 1. So it looks, that's super complicated. And then you could find like terms or whatever and go from there. But we'll just stick with the multiplication one. It's a lot easier. So look at that. The first one was like 15 minutes, and I did that in less than 10. You got to be impressed.